Hello everybody. So today I will talk about calculus. The topic today is about application of the derivative. So now I will show you how to answer the function. This one has one local minimum and one local maximum. So now I will show you how to answer. First, we need to find the domain in here. We know that x to the power of negative number 1, that is about 1 over x. So in this situation, d equals to r, and we need to reject about number 0 in here. So we need to find the limit on the left and the limit on the right of number 0 in here. So for the limit on the left, so when we put number 0 in here, you got 0. But when we put number 0 on the left, this one we have the negative number. So we know that 1 divided by 0, you got infinity. So the function in here, we have negative infinity. So for on the right, we will have positive infinity. The next one, we need to find the limit when x go to positive infinity. When x go to positive infinity, 1 divided by this one, you got 0. This one we have number 2. Number 2 is about positive. So this one in here, they will go to positive infinity. Now for x go to negative infinity, we have negative infinity. Next, if we want to find the local minimum and local maximum, we need to find first the derivative of the function. So first, the derivative of x, we have number 1. The next one, that is about negative 1 over x squared. So the next one, we need to put first the derivative of the function equals to number 0. That means this one equals to number 0. So I will put this one go to the right. Later that, we divide both sides by number 2. Now I will put x squared go to the left. Later that, we put the square root for the both sides. So we have x equals to number 1 and x equals to negative number 1. So we put number 1 go back in here. So we have f of number 1 equals to number 4 and f of negative number 1 equals to negative number 4. The next one, we need to draw the table. That is about variation table. So we have x, first the derivative of the function and original function. So I will put negative number 1 and positive number 1 from here. And number 0, because we have the domain s cannot equals to number 0 in here. Because number 0 cannot define in first derivative of the function and original function. So we put the double lines in here. So for this one, you got 0 and 0 because they are two critical values. So that's why we have 0 and 0 in here. The next one, I will put about s equal to number 2 to know the sign of this one. So I will put s equals to number 2. Go in here. And we have 3 over 2. 3 over 2, that is about positive. So we have the positive sign in here. Now we put 1 over 2. Go in here. And we have negative number 6. So negative number 6, that is about negative. Now we put s equals to negative 1 over 2. This one we have the negative sign. And s equals to negative number 2. This one, that should be about positive. Now we have the formula. When first derivative of the function is greater than number 0, so f of s should be increased. The next one, when first derivative of the function is smaller than number 0, so f of s decrease. Now we can apply the formula in here. This one increase, so they will like this. This one decrease, or this one negative, so that should be about decreased. So this one is negative, that should be decreased. This one positive, that should be increased. Now we know that when s go to negative infinity, this one negative infinity based on the limit. This one negative infinity from the limit. This one positive infinity and positive infinity. So number 1, that is positive number 4. This one we have negative number 4. Now according to the table, we can see that this one, that is about local mass. This one, that is about local mean. So when we write the answer, the function has a local mass at s equal to negative number 1 with the value negative number 4 and has a local mean at s equals to number 1 with the value number 4 in here. This is the end. Thank you for watching.